This is the beast, the hidden enemy. It gets its name from those protein barbs which resemble the corona of the sun. If you understood the chemistry and mechanism of soap and water, you would begin to appreciate how the simple act of washing will allow surfactant molecules found in soap to surround and destabilize many contagious viruses, from the common cold to COVID-19. The purpose of this video is to explain why soap, plain old soap, is the most effective defense we have against this worldwide pandemic. First, some specifics on the structure of the coronavirus itself. In the inner core is its genetic RNA information, ribonucleic acid, a single-stranded molecule unlike DNA, which is a double-stranded deoxyribonucleic acid. That RNA is encased and protected by a fatty proteinaceous membrane. Think of the virus shell as this microscopic globule of oil that holds everything together, including its genetic RNA core. That oily outer layer bonds, fuses, and penetrates your oily skin cells. It then delivers its genetic information, which creates a bunch of new copies of itself, and then begins to hijack your natural resources. Let's now talk about the surfactants found in soap. Each surfactant molecule has on one end a hydrophilic or water-loving component. Hydro means water, philic means to like. That hydrophilic segment associates with water molecules. On the other end of the molecule is its lipophilic or oil-loving component. Lipo means oil or fat. Lipophilic is also synonymous with the term hydrophobic, which means water-fearing. And that segment associates with water-incompatible substances, such as oil, fat, grease, grime, or dirt. The word surfactant is actually a contraction of three words: surface, active, agent. Therefore, it's a molecule that is active at the surface. Surfactants belong to a group of chemicals known as amphiphilic, molecules that contain two different moieties. The prefix amphi means both sides, like amphibian, something that can live in both water and on land. Let's fill up our vessel with water. When soap or surfactant molecules are immersed in water, they migrate to the water-air interface. Just as oil and water don't mix, surfactant molecules position their lipophilic or oil-loving moieties away from the water, while their hydrophilic or water-loving segments remain anchored in the water. This accumulation or adsorption at the surface reduces water's intermolecular attractive forces, which results in reduced surface tension, basically making water wetter. Once the surface is completely saturated with surfactant molecules, any additional surfactant entering the system will first attempt to penetrate and join the crowded interface. If unsuccessful, they are forced to an alternative lower energy state by rearranging and aggregating themselves into tiny clusters called micelles. We call this stage the critical micelle concentration. Their lipophilic ends point inwards, associating with themselves, while their hydrophilic ends protrude into the surrounding water molecules. That inner lipophilic domain allows micelles the unique ability to attract and capture any water-incompatible material, like oils and fats. Think of a captured oil globule and the encasing micelle as a pin cushion. The cushion can be anything that is lipophilic, and the pins are the surfactant molecules. The pin's needle is oil-loving, and the pin's head is water-loving. When you wash your hands, the shear force breaks down any lipophilic contaminants into fragmented shards, which are immediately encased by surfactant micelles. The lipophilic ends penetrate the contaminant, and the hydrophilic ends allow those contaminants to be dispersed throughout the water, which ultimately gets washed down the drain. If you found this video helpful in explaining how soap's micelles combat the coronavirus, feel free to comment below and share with your family, friends, and colleagues. If anything should go viral, it's scientific understanding to help battle this dreadful disease. Thank you, keep safe, keep healthy.